Ruby. Hi everyone, this is the Ruby Junior Developer Book Club, and we are covering Eloquent Ruby, chapters 7 and 8 for this episode. And my name is Newton, the host, and Nelson. So far, we've covered, I think, the previous 6 chapters along with Pedro, but he hasn't made it today, so it's just the two of us. Yeah. How does that sound?
Good.
I
It's
don't know, I've
perfect.
never done that before, so this is like my first time.
Well,
So can we start?
yeah, we've started.
Okay. So when you're talking to people and they tell you everything in Ruby is an object.
Mhm.
Yeah, I think that is one of the statements that were made more clear when I was going through chapter 7. Like, what does that statement mean, and what are the implications of that statement when you're writing programs? And also, I got a review of certain basics like inheritance, whereby you have classes like now the object class, and then they tell you how it provides certain methods to most of the other classes or the child classes that inherit from it. So going through the book, chapter 7, at this section where we have a quick review of classes, instances, and methods. Are we on the same page?
Yeah.
Yeah. So a quick review of classes, instances, and methods. So first and foremost, what is a class? The author here created a class named document, as you can see in that code. And then what is an instance of a class? When you look at the code that follows the statement, which starts with second, classes are also factories, in the sense that classes are factories for making instances. So you said doc, and then you say document.new, and then you supply the argument. Doc in this case is an instance of the document class, right?
Hmm.
And then what is a method? A method, for the context of this code, we have two methods, I think, with the other ones being omitted for brevity. We have a method named words, which gets the content supplied while making the instance of the class and splitting that content. And then we have another method called word count, which tells us the number of words, I think, in the content that is supplied when you're creating a new instance of the class. And then the author says once you have an instance, you can call methods on it using the more or less universal object-oriented syntax of instance dot method name. So he has doc and then dot word count. Remember, doc is the new instance of the document class. So we are calling the word count method on it. And that is a way of sending, I think, messages to objects. In this case, doc is the object and word count is the message or the method. So proceeding on, we see a recap of self and what it means in the context of this code, or more specifically, what self is in the context of this code. So when considering this about me method, which has been added to the document class, we have three puts specifically. One is letting us know what self is in the context of this code when it's run, and then the second put is calling title on that current self, and then the last put is calling word count on that current self. I think title is a method that is one of those methods that were omitted for brevity, right? The
It,
method he calls in this code, the about me method. I don't know if you remember.
So
You've seen the method.
yeah, so we're on page 75. We're on doc.about me, right?
Yeah.
Hmm. And so
Yeah, the method I'm referring. Mhm.
say that again.
The method I was referring to is the one, this method called title, the one he's calling on self, the current object self in the second puts line. You seen it?
Mm, yeah, self.title.
Yeah. So what I was saying is that it could be one of those methods that had that were omitted out in this case for brevity reasons.
Yeah, you don't see it
Yeah.
there.
Yeah. So I don't know what this is. What the first puts is outputting this thing called document and then followed by a zero and an X. I don't know what that is.
So it's a hexadecimal value, which can either be like the ID of the document, but it may also be just the memory location. Because a lot of memory locations are listed as hexadecimal. So that document there, whether it's, and I'm not sure which one of those it is, if it's just an ID or if it's a location in memory. It's possible that it's likely, if I were betting, that it would be a memory location. So when you're comparing two objects, you can look and see if that value is the same or not, and then you know if it's the same object that you're looking at or if it's a different object.
Okay. So proceeding in the context of this code, remember we created a new instance of the document class, and that instance is called doc. In this case, self will be referring to that instance of the document class. And I think you can see that when with the output of the second puts, when they call the title on the self, it's returning my title is ethics. And I think you can see that while instantiating the doc object, we passed in ethics as its title, as the value of the title. And I think by the fact that it's returned here when we call self.title, that shows you that the current equivalent of self. And then following on to the self.word count, still self is the same as doc, and yeah, it's showing you that it has forward, which still you can see that by counting the number of words that were passed in initially while instantiating this while creating this instance of the document class. You can see that we passed in forward. So by it returning that the value is 4, that shows you that self is the current instance of the document class, which is doc. And then I think we proceed from there on. He brings in inheritance by saying every class except one has a superclass, some place that the class can turn to when someone calls a method that the class doesn't recognize. If you don't specify a superclass when you are defining a new class, kind of like for the document class we created above, the new class automatically becomes a direct subclass of object. Our document class, for example, is a direct subclass of object because we didn't specify the class it inherits from, and also given the fact that all classes will have object as a superclass. So all classes will inherit from object. And moving on, we'll say that by the fact that most of these classes have object as a superclass, we'll have objects. No, we'll have methods that are part of the object class being available to all these child classes down the line. So proceeding to that part of objects all the way down, here we actually have like um, a few different types of objects, and we are calling methods on them. We have ABC, which is a string dot uppercase. We are calling the uppercase method on the string ABC, and then length on the symbol ABC. And I'm not sure what what type of object this is.
It's a
The one
we
the one in
we've
the
seen
front.
it we've seen it before in the chapter on regular expressions. That's called a pattern.
Ah, okay. So basically, the highlight here is that he's showing you how you have an object on the left and you have a method on the right. So you're calling the method on the right on the object which is on the left. And this object could of course be of any type. It could be a string, it could be a symbol, could be a hash, could be an array, and it could also be true, which is a boolean. True is a boolean. So when you say true dot class, it returns a true class, which shows you that you have a true class to which this true object belongs. Same goes for this next line of code, which asks if false is nil, and it's returning false because false is not nil, and false is rather, I think still a boolean, similar to true. And then when he calls a true.class.class, it is returning class. I think this is calling like two classes above. It moves from the first class and then it goes to the class above that. And lastly, when he calls nil.class, it returns a nil class to show you that this nil object is belongs to this class, which is a nil class. And then when he asks nil.nil question mark, it returns true, signifying that this nil is actually I think a nil object. I think that's here. So the next section is the importance of being an object. And here he goes into more detail about the object class. And to read a bit from that section, actually, if you reference it with a variable, it's probably not just an object, but an object, an instance of the object class. Since virtually all Ruby objects can trace their ancestry back to object, virtually all Ruby objects have a set of methods in common, the ones they inherit from object, which is the object class. So the next time you call class, the one we've seen before, or instance of, to see just what sort of object you have, thank the object class for supplying those methods. The object class is also the source of the well-known toString method, which returns a string representation of your object. So I think that is kind of like very straightforward. And then for the next session, he brings in, or he introduces a concept of overriding the methods that are made available by the object class. We've seen that the toString method is made available by the object class. So when we write a custom method of the same name and we add it to the document class and we have it return output that we've specified, that method we've just created will override the toString method that is initially provided by the object class. And if we were to call this this new toString method, which is defined as part of the document class, we'll say that it will return the output we've specified. In this case, we'll have document returning the title by the author.
Your screen froze. Are you still there?
You back there. My network was kinda not stable. So I think we can proceed.
Okay. Um, it looks like you disconnected and then it reconnected.
Yeah, this network in my country is like, yeah, it's unstable. So are we on the same page up to that point?
So you last had me at page 78, right before we get to public, private, and protected. We were still in the section of the importance of being an object.
So I think I'd mentioned the part of the overriding the methods that are provided by object.
Oh, yes, yeah. Yeah,
Yeah, yeah,
we got that.
yeah. So I think proceeding from there on, I think the next page really ushers in like or mentions other methods that are provided by object. For example, this CMD method, whereby I think he's saying it's called the eval method. Sorry, instances of object also inherit some more esoteric talents. For example, the eval method defined by object takes a string.
We lost them again. I'm waiting for them to come back.
Yeah, I'm
Okay,
very
you're
about that.
back. Yeah, that
I'm
eval
having issues
method
with this
is
thing.
it's okay. Um, that eval method is very interesting to me. Um,
It's, it's off again.
oh, is your network still unstable? Nope. Mm. Okay. Yeah, it's going on and off.
How about now? Yeah,
Well,
I
yeah,
mean,
I can see you now.
okay. So I was talking about the eval method
Hmm.
as part of the methods that are defined that are provided by the object class, along with the toString. And I think I mentioned that part regarding how to override these methods. So I think I'll continue to public, private, and protected. Like a lot of to read and to get an excerpt from the book. Like a lot of object-oriented programming languages, Ruby lets you control the visibility of your methods. Methods can be either public, in that case callable by any code anywhere, or private or protected. Ruby methods are public by default, so up to now all of our document methods have been public. You can make your methods private by adding private before the method definition. So what's the diff here? I'm just going to try to highlight the difference between a public and a private method. So before, at the start of the chapter, we created a new instance of the document class and we named it doc. And then we called word count on doc. In that case, word count was a public method that you could call on any instance of the document class. But then when we make the word count method private and we try to call that method on an instance of a document class, in this case doc, we'll see that we'll run into an error. I'm not sure what the error is, but we'll run into an error because a private method shouldn't be called outside outside the class, I think. So in that case, if word count is a private method, you can't call that method and specify an object explicitly outside the class. So you'll run into an error. I think to quote from the book, Ruby's treatment of private methods is a bit idiosyncratic. The rule is that you cannot call a private method with an explicit object reference. So if word count was indeed private, then calling word count on an instance of the document class named doc will give you an error.
Yeah, and I think the error is going to be something along the lines of, um, you know, undefined method word count on doc, whatever
Okay.
variable you tried calling it on.
So I don't know. So it seems like the time might be running out, and should we proceed to the next chapter?
Sure. Yeah.
Yeah, because I think the whole public, private, and protected thing is kind of like a common thing. So okay, to me it sounds like it's straightforward. I don't know about you.
Yeah. Yeah. It's
Yeah,
pretty straightforward.
yeah. So we could just proceed to the next chapter, which is embracing dark typing, not dynamic typing. So I think I'm just going to try to explain this how I understood it. So let's say you have a variable named x in Ruby, and you say x is equal to a string, and then on the next line you say x is equal to, now let's say, an integer, and then on another line you say x is equal to now let's say an array, right? So when Ruby is running this code, contrary to, let's say, a language like C, I always hear you reference C. Ruby is not going to throw an error regarding that the fact that you've had so many values equal to x, whereby you have a string equal to x, and then you have an array equal to x, and then you have an integer equal to x. So I think in a language like C, you'll have to specify that x, I think string x, and then you equate it to a value while you're defining a variable, which is as opposed to Ruby, whereby you can have x, which is a variable, and it is referencing objects of various types, and you won't have to run into an error when the object is being compiled and then run at runtime. I don't know if that makes sense.
Yeah, that makes sense.
Yeah. So another thing, I think it's also part of this chapter, is the whole duck typing concept, whereby they say if it behaves like a duck and it moves like a duck and it quacks like a duck, then it's definitely a duck. So when you're sending a method, or when you're calling a method on an object, mm, Ruby won't care what type of object this is. Ruby won't care if it's a string or if it's an integer or if it's a symbol. What Ruby will care about is if this object can respond to the method. And if the object responds to the method, then you'll get to know what type of object it is. Now let's say we have a string, and the string is ABC, and we call the two the we call let's say dot uppercase on the string. So if we have the string being turned to uppercase, you'll know that this object is a string, and not, let's say, an integer or an array for that case.
Yeah, so it's interesting to me that these two chapters are back to back with each other, because the idea the ideas of subclassing in the previous chapter, where you're using inheritance to link some type of relationship between two different objects. Like you have an object, it has a parent, right? Um, you have that capability to create parents and children. But what ends up happening in large code bases is if you rely on inheritance too much, it becomes very difficult to change. You sort of cement in the relationships, and so to to be able to like be more flexible. I think uh, this chapter here starts the conversation of not sort of relying on that hierarchy of parent to child classes, but instead starting to think about building relationships based on the like modules, for instance, where you have a, a certain set of um, like functions that you just mix in to your class. And
Okay.
as long as two objects include this mix in of some module, then you can treat them in the same way, where you can have an array of these objects and you can call like toString on all of the objects and they'll do the right thing. And there, you didn't have to set up a hierarchy. You didn't have to specify, okay, this is a parent, this is a child, and they're all going to inherit this method. No, instead, you just on the fly can include those methods and end up getting the program to work. And it increases the flexibility and your ability to adapt and change to new requirements.
So one thing I quite didn't okay, one thing I found quite contrary to the whole, the not like the modules thing you've talked about, is that when you're looking at at various code bases now, like I've been going through the Kamal code base. I don't know if you've heard of Kamal,
Yeah,
the
yeah.
deployment. Yeah. So I've been going through the code base, and still they use things like inheritance. They don't completely do away with the inheritance. They use it, and at the same time they use modules. So how do you know that this time I'm supposed to inherit from a class, and then this other time I'm supposed to just mix in the behavior into the class?
I
I don't know
mean,
if
like everything, programming is an art form, and you sort of experiment. And when things go wrong, you take it back. Uh, so it's not like a perfect science. It's just like you're, you're writing an essay. You know, you can say, okay, you prefer to use these sort of techniques or those other techniques, but really, it's more of an art form. And when I say like prefer to use modules over inheritance, um, it's not to say that you can never use inheritance.
Yeah.
Sometimes it makes sense. Um, but you know what ends up happening sometimes is that you when you create like a deep inheritance tree, um, it becomes a real problem. But if you have a really short stack where you just have, you know, you're a parent and a few children, then like whatever, it's not a problem. Um, but when you start adding layers and layers to that hierarchy, then it should bring up a red flag to say, hey, you know, this might not work out later.
Okay. So is it okay for us to think of inheritance in this way? Like you have a class, I think they usually name them base. Base is usually the name of those classes. And then those classes tend to have methods that should be available for now, let's say like all these child classes that you're going to use down the line. So is it okay if I think about it in like you have a base class, it has all these methods that you're going to be calling down the line in several other subclasses, and then the sole purpose of that base class is to house those methods. Like this is where these methods should be, and then you leave the operations to the operations of actually calling these methods on objects and instantiating or creating new instances of these subclasses. You leave that functionality to the subclasses. Is it okay if I think about it in that way?
Yeah, that's a great way of thinking about it. The you know, the base class should contain that all the methods that should all of these other classes have in common, um, and that work in the same way. Where it gets tricky is where you have a child that really needs to do something different with like the title, you know, and that method where it's doing something different with the title. Um, if all the children have a different function definition for a title, let's say, then why is it in the base document? You know, that if you're going to have to
Yeah,
override it,
yeah, yeah.
unless you're going to put in there that it's going to raise an exception if it's not implemented, like you're really creating this contract when you're creating this type. And the contract says, I'm going to have at least these methods, right? And these methods you can expect to work in a similar way. Um, or at least, you know, that they should exist because I'm going to call this method on all of these objects. So they should all uh, know how to do this thing for themselves. Um, but again, you know, like if all of your children have a different definition for that method, then what is the real contract there?
So if all the children have a different definition of the method, that I think that means that the method shouldn't be part of the base class. I think the base class should be left for methods that are universal, like the functionality of that method is the same for all children. Is that the case?
Yeah, unless you really are going to call this method on everyone, and then you're going to say, okay, I expect you to have this method. I'm not going to define it in the base class, but I'm going to put it in the base class and I'm going to raise an exception and I'm going to say, hey, you have to implement this yourself because this is the contract that I'm going to create. Like I'm going to have this method called, you know, title, and I'm going to raise an exception if you don't implement this method in your in whatever child you create. Um, and that creates the contract. But if you're just having, you know, different methods, then maybe that method just shouldn't go in the base document.
Yeah. So I haven't gone through the Rails code base, but Rails tends to reference base a lot. Active record base, application controller base. Is it the same kind of thinking whereby you have methods in the base class and then you have various other classes inheriting from that method? No, from
Yeah.
that class.
Yeah, you'll have modules that mix in some behavior that bring in
Mm.
some methods of their own.
Okay. So I think my last question is which one is more organized?
Um,
Inheriting and mixing in. Like when you're writing a program, which one is which one keeps things more organized compared to the other?
I mean, I think a lot of times it'll just be a stylistic difference in terms of like how you understand the program. Like because so we're comparing. Oh no, we have 40 seconds left. Um, let's see. Yeah, I mean, it's just really it's a stylistic thing, and you're gonna do whatever it is you're gonna do. But just like I said before, a lot of times if you end up preferring the creating hierarchies too much, then your code is going to be a lot more rigid. Now, does it matter if it's more rigid? Maybe it doesn't matter. Maybe it's fine.